Hello once again, and welcome to another INB382 video demonstration. In this case, we're going to cover procedural flames. There are many ways of doing this, but this is one version I found on the web that I think is just a quite nicely set up approach that enables you to very quickly set up good sort of flame effects in 3D. So I'll just run it and you just get a feel for it. This is probably my favourite demo of the whole unit. And as you can see there, effectively it's a noisy texture in time, and the noise added to the structure, again like the Ito calculus that I mentioned in the lecture, enables you to get what approximates, quite visually, quite effectively, a flame. And that means, of course, you can apply this. This is just applied to a quad in 3D. Put together a stack of quads and you've got a volume full of flame. So there's all sorts of possibilities. This is just a nice intro, and it's a very simple way of doing flame. But again, as for all these things in the unit, there's a lot more out there you can draw upon and that you can use if you wish to generate better sort of simulations of flames. But here's a nice intro. So here's our flame. How do we do it? Going back here, again, as mentioned, it's the sort of the Ito calculus idea of having a more deterministic underlying function with noise added. So here we go. We have as our deterministic function. We can see here that we've got a texture. The texture forms the basis of the flame in 2D. And as you can see there, it just contains this color ramp from an orange down the bottom, going up to a bright yellow at the top. Maybe you could add a blue tip if you so wish. Whatever, this just sort of gives us the basic structure of the flame. And you can imagine this is like a candle tip. The basic structure is this sort of teardrop. The key thing then to add to that, one of the many key things that I've been talking about, is this noise. So once again, I use the same script to generate the noise. So we just assume that. But moving along to the flame shader, there's probably silly dialog box there. Putting together lots of demos this morning. The whole idea is that, again, we are adding together octaves of noise. So remember, look at the lecture. And we see here that this is actually a different way of doing it. I just followed the demo that I found. We have a method here that uses our 3D noise function sampler, suitably scaled and perturbed. And here we have the proper turbulence function, which is just 4 calls to that function. It's an unrolled for loop. So it's the same thing as the for loop, but we do it explicitly, and we can see there that our sampling position in the space is multiplied by a power of 2 and then divided by a power of 2, or multiplied by 1 over that power. So this gives us this turbulence function, again, which is driving most of the effects that I've been showing you in the lecture. And then the basis of this is that the idea that we're applying this function in x and y, and using the the flame's position in xz space on the plane, and then the y position of the flame coming in. So the x position is just the radial distance in the xz plane, and the y position just stays as the y value. But the really cool effect is that the y value, as it's changing in time, because we've got an animator on it, so I think if we go up here, there we go, see the underscore time being added to a time factor, which is changing the noise position on the output. So that's generated by Unity, and this enables us, I'm modding it with 10 by the way, so we don't get a ridiculously sized texture coordinate. That noise position, when passed through, comes out as the flame position, which is probably a bit obfuscated. The flame position there has that, the flame scale, the flame translate applied. What we have to then say though is that down here we're worried about changing the Y position of the texture coordinate. Because if you think about it, you're perturbing everything in Y. Because the flame shoots up, so it's not going to move much in X. I guess we could add some noise to X if we wish. But if we add noise to the Y position, it moves it up and down relative to its previous position in a turbulent manner, such as here. And this means that we end up with this sort of noisy, plasma-like effect. So if I run it again, you can see that the noise is transmitted up through in Y. And that's where the noise is added, not so much in X. And that gives us this flame effect, which produces what is really quite effective and very pretty sort of procedurally generated flame. So again, you can play with the color ramp. You're now using the texture as a color ramp. So going back there and turning it off, there's your color ramp and also your general shape of the flame. Actually use the original texture here. So if you wish, the idea probably then would be that you could generate another flame texture using different colors. Maybe you want to use really way out psychedelic colors in order to produce some sort of, magical plasma effect or flame effect for a wizard in a game or something like that. So you can use this texture as your basis to form the colors, but the noise added along that y-axis generates for you the appearance of the flame that we show here. So there's a very simple flame shader using Perlin noise. Thank you very much for listening.